Modern researchers try to bring to life the idea of a scientist who lived more than 100 years ago. We are talking about Nikola Tesla. In 1891, the inventor developed the Tesla coil, a resonant transformer that transmits electricity without wires, but only over short distances. Due to its limited capacity, it was not used. However, the scientist was not going to give up and created a project for a power plant that could cope with high-voltage wireless power transmission. Tesla tried to use it to transmit messages wirelessly over long distances. Unfortunately, the JP Morgan investor refused to provide additional funds for the tests, and in 1906, the project was cancelled and closed. Tesla's dream was to place huge towers around the world that could transmit power wirelessly to any place, powering houses, enterprises, industrial facilities, and even giant electric ships in the ocean. Tesla died, unable to fully realize his idea of wireless electricity, but his followers continued the work of an outstanding scientist. In 1964, microwave electronics expert William C. Brown first tested a helicopter model capable of receiving and using microwave beam energy as the direct current through an antenna array consisting of half-wave dipoles with highly efficient Schottky diodes. In the 1970s, American engineers actively developed the technologies necessary for the wireless power transmission from space. It was assumed that this would make it possible to build a solar station in orbit that could efficiently generate energy and transmit it to Earth. In 1975, NASA presented the most successful option of this approach to date. They were able to organize wireless transmission over a distance of just over 1.5 kilometers with a power of more than 30 kilowatts. Although the transmission turned out to be quite successful, more than 82%, it was necessary to use a receiving antenna with an area of 24 square meters, and a reflector antenna with a diameter of 26 meters generated a beam of radio waves. Thus, to transmit a huge amount of energy over a distance of hundreds of kilometers, much larger antennas would be required. That was in the last century, but what about the success of the wireless power transmission industry today? For example, the well-known wireless phone charger works through the electromagnetic induction and allows you to transfer energy over a distance of up to 4 centimeters. The charger is connected to the network and generates energy in an electromagnetic field using a built-in inductance coil. Such a device as Xiaomi's Mi Air Charge wireless charger is already capable of charging smartphones at a distance of several meters. And not just smartphones. The device uses directed microwaves, allowing you to distribute energy to several devices in the room and simultaneously power electronic devices. The power of such charger is 5 watts for each consumer. If you want to charge a more powerful device, then here is the solution from the Electrion Israeli company. It proposed an innovative way to charge electric vehicles. The new technology option is planned to be placed directly on the road. On a kilometre stretch of road between the cities of Brescia and Milan in Italy. With its help, it will be possible to charge electric cars without connecting to charging stations, either during parking or while riding. In theory, autonomous vehicles could drive around the clock without recharging. Electric vehicle charging highways run through a copper coil system embedded in the asphalt. The energy from these coils is transferred to the vehicle's batteries through magnetic induction. The charging system requires the control unit to be located on the side of the road and the receiver to be installed in the chassis of each vehicle. As you can see, science does not stand still and uses wireless technologies to the full. But what about the power transmission over long distances, which Nikola Tesla dreamed of? The idea of transmitting energy over long distances is of great interest to the US Air Force and Navy, as it could help supply military bases with electricity. Therefore, the Pentagon developed Scope M project. A group of researchers led by Christopher Rodenbeck started work on this project. The device developed by the team during the tests transmitted microwave energy at a frequency of 10 GHz, which guarantees reliable operation even in rainy weather with a power loss of less than 5%, as well as safety for nearby animals and people. As a transmitter, the engineers used an ordinary reflector antenna with a diameter of several meters. A square antenna receives radio waves from many receivers connected to rectifying diodes to generate direct current. Experiments have shown that the system can transmit energy over a distance of 1 kilometer with a peak power of 1.6 kilowatts. Scope M showed a good 60% efficiency, which, according to the developers, is not the limit. In the future, this technology can be used to transmit electricity from power solar orbital power stations to Earth around the clock. Emroid, New Zealand startup, has come closest to fulfilling Nikola Tesla's dream. It began with an idea from entrepreneur Greg Kushner, who became aware of a cheap and reliable way to provide electricity that would bypass complicated electrical networks infrastructure. On his request and with the state financial support, scientist Ray Simpkin developed a prototype device for wireless power transmission. The system uses a transmitting antenna, a series of relays and a receiving rectenna. Although such a number of devices seems impressive, each of them is, in fact, a square mounted on a pole. The spectrum of waves used in these generators intersects with the frequencies of industrial, scientific, medical enterprises, as well as frequencies used in Wi-Fi and Bluetooth. Energy passes directly between certain points. There is also a special protector that immediately turns off the transmission of energy as soon as it detects any object approaching, a bird or a drone. The company emphasizes that the technology works in all weather conditions, including rain, fog and dust, and the transmission distance is limited only by line of sight between each repeater. The energy loss during transmission on the prototype is 30%. Moreover, the efficiency of the receiving antenna from the radio-absorbing metamaterials is almost 100%. Kushner's company got investors interested in the project and entered the big market. Since October 2021, PowerCo, New Zealand's second largest electricity supplier, has tested a prototype device. The device transmits a current with a power of only 2 kilowatts, but the developers are sure that the power, as well as transmission distance, can be easily increased. The developers do not plan to get rid of the usual electrical networks, but propose to use the device in hard-to-reach areas or to quickly restore power supply to emergency sections of the network using equipment with antennas. Moreover, the installation of such devices will help to transmit the energy from renewable sources to regions with an unsuitable climate for generating green energy. Nevertheless, there are still obstacles to the Emroid infrastructure development. The startup has to convince people that radiation will not harm them. The authors of the project say that Emroid uses non-ionizing industrial, scientific and medical frequency range to transmit energy in compliance with international safety rules for its use. So if the Emroid development turns out to be successful, the world, although belatedly, will be able to realize Nikola Tesla's dream. Just imagine what amazing opportunities will open up for humanity, and how they will change our lives. The history of wireless power transmission hints to young scientists that they should not be upset by the futility of discoveries. Maybe their time has just not come yet.